All right, this is performance task number 5. So this is based off of a mystery substance displayed on a heating curve. I just sort of copied it down here, but ignore all these words just for now. So we're going to be answering some questions just based on this little heating curve. First question is, what's the melting point? All right. So looking at the heating curve, we can just base it off of sort of knowledge. The first little rising point would be where a solid is. That's how I started this. So I saw, oh, that's where the mystery substance is a solid. Boom. All right. Oh, we have a flat part. I'm going to assume that's where the solid is melting. So, the melting point of the substance would then be located at just before the liquid and solid. This is the point in between the melting point. Now we're going to find the boiling point. Ignore that I wrote vaporizing here. The boiling point, so here's what I thought, solid. Here's melting, moves right over to liquid. So for the substance to then be boiling, it would have to then be at a past liquid. It would already have to be a liquid. Then moving further along, it would then be boiling. Just pretend that it says boiling instead of vaporizing. The third question is finding the condensation point. The condensation point would be located at the same point as the boiling point. So I would then say that the condensation point is in the same place as the boiling point, which is located at 90 degrees Celsius in this question. And also the melting point is located at 50 degrees Celsius. All right, next is the freezing point. We're going to move back. The freezing point is usually located with the melting point. Freezing would turn the substance back into a solid. Melting would turn this substance into a liquid. So the freezing point would also be located at 50 degrees Celsius. The next question is, what phase is the substance located at 70 degrees? So I just marked this out like 10, 20, 30. So we're going to go over to 60, 70. 70, pretend there's 70 degrees here. Yeah, move it over. The substance would then, the substance would be a liquid at this point, at 70 degrees. That's what the phase it would be a liquid. Next is, what phase or phases are present at 90 degrees? All right, 90 degrees, bring it right over. Oh man, it's at 90 degrees, which is the melting point, or not the melting point, the condensation and boiling point. So at this point, the substance would be sort of both. It would be a liquid and a gas, or a liquid turning into a gas at 90 degrees. And it would be both. It would be a liquid and a gas. Beyond what temperature is the substance only a gas? Let's grab here. All right, 90 degrees. You see that it starts to go up at past the boiling point. So I would say past 90 degrees, this substance would only be a gas. All right, now we're moving on to some really fun math. All right, number 8, this would be question 8 on the performance task. So just at the top here, I wrote down like what sort of laws they would each follow. So oh man, this is not number 8, this is number 7. All right, number 7, the question is, a gaseous sample of a substance has a pressure of 1.12 atm and a volume of 2.50 liters. If the pressure is increased to 1.50 atm, what's the new volume of the gas? All right, so we have pressure 1, which is 1.12 atm, and then the volume, which is, or V1, which is the first volume given, so it would be 2.50 liters. Next we have what it increases to, which is 1.5 or ATM. That's what should be there. So we're gonna do this little equation following Boyle's law. So we plug in 1.12 ATM times 2.50 liters. That would equal, or because pressure P1 V1 equals P2 V2, and we would plug it in for this equation. So then we would have 1.50 ATM times V2. So I just solve for this, and the next equation that we would then get, we would solve for V2. So it would be 1.12 ATM times 2.50 liters over 1.50 ATM. Then we would solve for that number. We get 1.87 liters. That would be the pressure, that would be the volume of the gas at 1.50 ATM. All right, this actually is number 8. This is supposed to be number 7. All right, this question is a 0.85 mole sample of gas has a volume of 1.25 liters. If 0.55 moles of gas are added to the sample, calculate the new volume. All right, so we're gonna use Avogadro's law. So V1, V2 divided by V2 equals V2 divided by, V1 divided by N1 equals V2 divided by N2. All right, so we have V1, which is 1.25 liters, N1, which is 0.85 moles, and then N2, which is 1.40 moles. All right, so first we would solve for V2, so we had 1.25 liters over 0.85 moles equals V2 over 1.40 moles. So we need to solve for V2. So we do 1.25 liters times 1.40 moles over 0.85 moles. And that would equal 2.06 liters. That would be the new volume if 0.55 moles of gas are added. All right, number 9, exciting. This is following the ideal gas law, so it would be PV equals nRT. That's supposed to be a little lowercase. So this question is a gaseous sample of 1.65 moles of gas has a temperature of 305 K and a volume of 2.75 liters. What is the pressure of the sample? All right, so let's use the given. So the volume would be 2.75 liters. The N in this equation would be 1.65 moles, and the T would then be 305 K. And this is just following the ideal gas law for the substances. That would be R. All right, so this is, we need to solve for P, so P equals nRT over V. All right, this is the equation using the numbers we plugged in. So 1.65 times 8.314 times 305 over 2.75 times 10 to the negative third. And that would give us 1.013 times 10 to the 6th P.